Histograms, tones and contrast. Much of the information in this lesson comes from the website Cambridge in Color. Many of you probably have no idea what I am talking about when I say histograms. Understanding histograms is probably the single most important concept to become familiar when working with pictures from a digital camera. So the histogram can tell us many things. It can tell us whether or not our image has been properly exposed. It can tell us whether the lighting is harsh or flat. And it will tell us what adjustments will work best. So this is what a histogram looks like, and I have enlarged this tremendously so it doesn't look so pretty. But what we see is a chart of pixels, really. So each pixel has a color, and this is for RGB. So when we're in RGB, we have red, green, and blue. And each color then, the red, the green, and the blue, can have a brightness value ranging from 0 to 255 for a digital image. And this is with a bit depth of 8 bits. Sounds a little bit confusing. A histogram results when the computer scans through that photo and all of those pixels, and it looks at the bright values and it counts how many there are at each level from 0 to 255. And so that's what we see. We'll use the term tonal range. This is the region where most of the brightness values are present, and this is called, like I said, the tonal range, and it can really vary a lot from image to image. Here's an example that you see the histogram associated with a photo, and they have marked the associating pixel counts with certain areas on that photo. So there's no real ideal histogram. There's nothing that we can say, okay, this is the model histogram. Let's make all our photos look like this. That does not exist. Okay, so there's no ideal histogram in which all photos should mimic. A histogram, remember, is a representation. It's representative of the tonal range in that photo, in that scene, and it tells us what that photo is conveying. So in the example here, it contains a fairly broad tonal range. If you look at the histogram, it extends from far left to far right, all of those values, 0 to 255. And so those markers are illustrating where the regions in that photo map to the brightness levels on the histogram. You can see in the histogram by just reading it, that's what we do, is we read a histogram. There are very few midtones. Look in the middle. That pixel count there is fairly low. There's not a lot of pixels in the middle. So we see in our photo, or we can read it and say, there's very few pixels in that mid-tone area. There's a lot of shadow area, plentiful shadow regions, and plentiful highlight regions. If you notice that it sort of goes up on the right and it goes up a lot more intense on the left, that's the shadows. So if you associate those markers, you can kind of start identifying how that pixel number is being counted. So the histogram, we could say, has a high pixel count on both far left and far right. If we look at one more example here, here we see a photo, and it's a photo of a boat with a reflection of a building. So when we look at the lighting here, this is kind of like conditions of ordinary, even lighting. If we have that, we're going to produce a histogram that peaks in the center, and then it gradually tapers off in the shadow and the highlights. So if you have an ordinary photo, pretty even lighting, you're going to get this histogram that kind of looks like this, peaks high in the center and very, very tapered, very low on the left, the far left, and the far right. So what this tells me is this photo doesn't have really direct sunlight reflecting off of anywhere. doesn't have extreme shadows, extreme highlights, we can see that there are some counts there. And especially if you look at the very far left, it's hard to see, but there's one column of pixels, same with the right. So we do have a little bit of direct sunlight somewhere in this photo. It's probably right in that top of the building and some of the window areas. That we get a little bit of highlight, a light area, and again the shadow area. There's some dense shadows right underneath the boat, and that would I say is probably the darkest in the boat and right underneath the boat. That's where we're getting those darker pixels. So when we talk about photos, we're going to talk about high and low key images, and it's a direct correlation with the histogram. Most cameras are going to produce mid-tone centric histograms when they are in automatic exposure mode. So the camera is trying to automate the exposure, and so it's going to push those pixels towards the middle. So that distribution of peaks within the histogram not only looks at as kind of the exposure, but it's going to depend on the tonal range of the subject matter themselves. Okay, so if we say we have a low-key image, or if our photo is low-key, that's where the images, most of the tones occur in the shadows. If we say it's high-key, the photo is high-key, most of those tonal ranges or tones occur in the highlights. So before a photo is even taken, you need to assess whether your subject is high-key, meaning most tones in the highlights, or low key, meaning most of the tones are in the shadows. So if you look at the two examples here, the Dalmatian, lots of bright pixels there. So that I would say that's pretty high key. That means there's a lot of highlights. Think high and highlights. And then the picture on the left is low key, and you can see a lot of darkness and shadow areas. So we know we're going to get a lot of those pixel ranges, the tonal range, and the pixel count is going to be towards the left of my histogram. So when we take a picture with our cameras measure reflected light as opposed to the incandescent light, and so they are really unable to assess the absolute brightness of the subject. Most cameras will just estimate how bright an image should be, and a lot of times this results in an image whose average brightness is placed in those mid-tones. So if we look and analyze high-key scene versus low-key scene, a lot of times it requires you as the photographer to manually adjust the exposure because the camera is just going to kind of automatically guess where it should be. So the rule of thumb to take away from all of this is that you're going to have to probably manually adjust exposure whenever you want the average brightness in your image to appear brighter or darker than the mid-tone. Let me show you an example here of overexposed and underexposed. So using, again, that camera auto exposure setting, this, remember, puts those average pixel counts in the midtones. And what happens sometimes is you get underexposed or overexposed. Most digital cameras are better at reproducing low-key scenes than high-key scenes. Back to this example, remember high-key have a lot of highlights. Low-key have a lot of dark areas. High for highlights, low for lowlights, I guess you could think of. So most digital cameras are better at producing low-key scenes than the high-key scenes because it prevents an area or region from becoming so bright that it turns into a solid white, regardless of how dark the rest of the image might become as the result of that. So underexposed is usually better than overexposed if you were to err out either way. When an image is overexposed, okay, so when overexposed, what happens is that detail, you tend to lose. Detail can never be recovered when an area in a photo becomes so overexposed that it becomes solid white. Then there's no information in those pixels. It's what we call blown up, it's blown out, it's clipped. Those highlights are just pure white with no information. So clipping, which we call this, when it blows up, it's so overexposed that it's solid white, It will happen when you're looking at water or metal, something where there's some kind of reflections and you get specular reflections, or the sun is also included in the photo. So a specular reflection is that bright glare that sometimes you get. If you've ever taken a picture with the bright sun, you'll get that as well. So, and it could happen with just a light if there's a really bright light source. So that's when clipping may happen, and that can be okay. So histograms, looking at these histograms and reading those histograms, they are good for knowing whether clipping has occurred, since you can really see the highlights that are pushed to the edge of the chart. So in this example here on the left, you can see there is, in the overexposed, some pixels, there's some clipping that has occurred. That means there's some that have just turned pure white without any detail, and I'm assuming it's because of that sun coming in. And the underexposed, you see the midtones are kind of pushed more towards the middle, not actually absolutely in the middle. And you can see that we're missing bright whites. We're missing that whole chunk of highlights, and so it makes our photo look a bit dull. I want to show you some more examples of how you can look at your histograms on your photos if you have Adobe Photoshop. You can also use some other photo viewers, photo editors, to see the histogram. Some of you will be able to see the histogram right on your camera. A lot of cameras have a built-in histogram feature, so you can look at the histogram as you're shooting your photos. So here in Photoshop, I've done a couple things, and I want to show you what I have done. I opened up my histogram panel. Here's my histogram panel. I'll collapse it and I'll open it. So I have chosen here to do a few things. I've expanded the view to see all of them. So if you don't expand the view, you just see sort of a composite where we can choose colors, we can choose luminosity, and we can choose each channel, or we can look at it in RGB. I'm choosing to expand it to see all the channels so that you can see how everything is laid out. I can also view this in color if it helps you understand, because we're dealing with the red, the green, and the blue channel. So to find the histogram panel, you go under Window and go to Histogram. The other panel I have open is my Info panel, just a couple down from histogram, and this info panel is going to help to show you some of the colors. So whether you look at the RGB or the luminosity, they're going to be fairly similar, and we'll talk more about luminosity in a future lesson. But what this histogram tells me for this specific picture is that I have a lot of pixels in the middle range. If I look here, I have one little spike at the end here, indicating that I must have some extreme highlight happening, and I know exactly what it is. It's a specular that's on this dragonfly's eye, actually, and I'll show you that here in a moment. And otherwise, my tonal range is fairly leveled out. I don't have high spikes in the highlights or in the shadows. It's pretty even toned here in the middle. So I don't know that I can really classify this as being low key or high key. It basically is a pretty level, straight tonal range. So when I use my eyedropper tool, which you can locate over here on your toolbar, and with my info panel visible, I can go through, I'm not clicking, I'm just dragging, and I can see my RGB values that are underneath my eyedropper. Now remember, in RGB, white is 255, 255, 255. So when I drag over top, and what I'm looking for is at the very end of my eyedropper icon, this indicates the color that's in that pixel right underneath of it. And you can see that my color here is 254, 253, and 248. That tells me that those are counting for some of those pixels up here at the right end of my histogram. Remember, the histogram goes from 0 to 255. So if I find my 255 here in the red, right there it is, this spot right here is a direct relation to the pixels that are being counted right here in my red channel. Remember, these are all my red pixel counts, green pixel counts, blue pixel counts. Now if I go right in here, this is another highlight, and the wings right in here. Somewhere there's the 255, 255. So this point right here that I'm over top with my eyedropper is the absolute highest. That's one of those few that are being counted right here on the 255. Okay, you can see even the blue channel has some. Now in the reverse end, the dark. So I'm looking for 0. In RGB, black is 0, 0, 0. So I'm pulling around in here and imagine it's probably here. It could be back in here. Sometimes you forget to look in the shadows, like in here. All of these are very low numbers, and so that means that these are all my dark values. Okay, so I don't have a lot of spikes like here I do on the white, so I don't have a lot of spikes of pure black, but there's a couple pixels in here that are. So this is a fairly even tonal range. Now let's go to one that I have. Look at this example and look at the histogram. Why don't you read the histogram for a moment? What this is telling me is I have some clipping occurring actually in my highlights, and it's really a mix between very low key, very high key. I'm missing all my middle tones. I don't have a whole lot of middle areas, which says I have a lot of extreme brights and a lot of extreme darks. So I do have a lot of contrast, but missing some of those middle areas. And like I mentioned, it's being clipped because you can see in the highlights here, it basically is cutting off, or it's even clipping it on the histogram, which tells me that it's clipping. And what that says is that I have a bunch of pixels in here, and here's one of them that's pure white, and now I've lost all the detail in that pixel. I can't get it back. If I play around in any kind of photo manipulation tool, Photoshop, Lightroom, whatever I want to use, there is no way I can gain back any kind of detail in the building right there because it's been clipped. It's pure white. There's no information there other than pure white. And I have the reverse happening where I have some very darks, but I don't really necessarily have it being clipped on the shadow area because I don't have a lot of pure blacks, and it does do a nice little fall down on all of my channels. Okay, so this is an example of extremes, and it very much highlights my highlights. It's a clipped photo is what you would say. It's been blown up. Here's an example where the histograms look a little different. Now notice I have some extreme highlights, and again I'm being clipped. Remember I said when you shoot into the sun and actually have the sun in your scene, you're going to clip. So this whole area in here that I'm dragging around with my eyedropper is pure white. That tells me this area has been blown out. It's been clipped. I have no detail other than pure white in this area. As far as this kind of a hazy, it does not have a whole lot of extreme contrast other than the sun. If I were to remove the sun, it looks like it's fairly mundane. I have some dark shadows down here, dark areas in these little islands with the mongrel trees. But other than that, this is pretty much a lower mid-tone. So all of these pixels in here are what's showing up in this area. This is my sun. This and the areas around the sun is basically calling for these pixels, and then the mongrel trees are right here. So you can kind of see that a lot of this is right in that mid-tone range. So as you look at your photos and find a way to view the histograms on your photos, you can start reading them and understanding what's happening. Like I mentioned, some of your cameras allow you to see the histogram as you're taking the photos. So you can analyze, is this low key? Is this high key? How do I adjust my exposure to make the perfect photo?